This is chapter 11, lesson 1, and in chapter 11 we are going to talk about similarity. So this is lesson 11.1. Now, the entire year in geometry we have been working with this idea of congruency. So we have found that an angle measure is equal to 60 degrees, or perhaps a side length, maybe side AB, something like that, is equal to 6 inches. In other words, it's always equal. Alright? And so we've been stuck in this way of thinking about always something being equal to something else. Now we're going to change our thinking a little bit, and we're going to talk about not if things are similar, but rather not if things are congruent, but rather if things are similar. So let's take a look at two polygons. Here I have a trapezoid and a larger trapezoid here. So we're going to ask the question, what does it mean for two polygons to be similar? Well, I just want to take the smaller one here and I want to just make some observations. So this is just kind of inductive reasoning. So the first thing I'm going to notice is that look at that angle right there in both of them. They're the same measure. Take a look at this angle right here. Look at that. They're the same measure. And if you look at this angle over here, they're the same measure, and then lastly this fourth one down here, they're the same measure as well. Let's take a look at the side lengths. Look at this, there's one side length. I'm comparing this right here, and if I drag this up down here, look at that. So it takes exactly two of these sides to make one side of the trapezoid over here. Let's check the top length. Look at that, there's 1, 2. So there's definitely a relationship there that stays constant. So this angle is congruent to this angle right here. And if this measure was 2, say, feet long, this would be 1 foot long. And the same relationship, or we might say ratio, exists for all the sides. So this leads us to be able to say, what is this idea of similarity? So the big idea here, and this is what you should take notes on, is that we can say two polygons are similar if and only if, and there's two conditions, and both conditions have to be true. Okay, corresponding angles have to be the same measure. Alright, they have to be congruent. The second condition is that corresponding sides not are congruent, but have to be proportional. So that means in our little example here, like for instance, this angle is congruent to this angle is congruent to this angle because they are corresponding. This angle is congruent to this angle, and then this angle is congruent to this angle. And this side, is in a relationship with this side of 1 to 2. This is twice as long. Same ratio for this side, same ratio to this side, same ratio for this side. As long as all four sides are proportional and all four angles are congruent, then we can say that this ABCD, this trapezoid, is similar to this trapezoid EFGH. Okay, last thing to point out is that this symbol right here means similar. That may be new to some of you. So similar is that symbol. Let's talk about an example over here. Let's just pull up the shade so we don't have to talk about one thing at a time. So in our example here, it says we have two quadrilaterals, one named SMAL, small, and one named BIGE, big. And we're supposed to find X and Y. So let's talk about the easy one first. Let's talk about Y. So all you have to do, because remember, if they are similar, and it says they are right here, if they're similar, all the angles have to be congruent. So the corresponding angle to angle Y is 83 degrees. So angle y has to be 83 degrees. Now for the other part to this, to find a side measure, we have to take a look at side LS and its relationship with side EB. And then we're going to take a look at how does side LA relate to side X. Well, if you remember from before, if the two things are similar, the ratio between the sides has to be the same. So that's why, if you look down here, we can say that 18 right here has a relationship with 24, just the same as this side, 21 feet, has with this side, x. So we have this nice proportion. 18 is to 24 like 21 is to x. Alright, so I'm going to cross multiply. 18 times x is 18x. 24 times 21 I've written right here. In order to solve for x, I need to say, okay, 18 times x. So I'm going to divide by 18. If I divide the left side by 18, I have to divide the right side by 18. And I'm going to take my calculator. I'm going to do 24 times 21. I'm going to divide by 18. And I find out that x equals 28. Quick question, what happens if I change the order around? What if I say 24 is to 18 like x is to 21? If you're looking, the order is, the ratios are simply flipped. And is that okay? Is that okay just to flip things around like that? And the answer is yes, as long as the same relationships are in the same spot, it's just fine. Here we have 24 relates to 18, and then x relates to 21. They're in the same order, so that works just fine. Alright, we have one last little idea here. It's something called a dilation. A dilation is something that you're actually familiar with. You're just not used to the word dilation. Perhaps you've heard of the word scale factor before. So we have this quadrilateral. We have all four vertices marked out with the x and y coordinates, the ordered pairs. And we are going to apply a scale factor of 2. So we're going to take each of the x and y coordinates, multiply them by 2. So negative 3 times 2 is negative 6. 2 times 2 is 4. And so we can do that to each of the vertices. And we get this new quadrilateral. Okay, and the result is called a dilation. Alright, so the larger one is the smaller one dilated by a scale factor of 2. So the big question here is, when you do that, when you apply dilation, is the new quadrilateral similar to the original one? And the answer to that question is yes, it most definitely is. So you should take notes on this. Okay, you should write down that dilations always produce similar polygons. If you're unfamiliar with that word dilation, then perhaps you could make a little note right here about how dilations involve enlarging something or reducing it using what we call a scale factor. Alright, so we have two big ideas from lesson 11.1. The first is that there are two conditions to show that two polygons are similar. The first one is that corresponding angles are congruent. The second condition is that the sides are proportional. Alright, and then down here we talked very quickly about what a dilation is and how they always produce similar polygons. That's it for lesson 11.1.